NEET 2021 question from mechanical properties of fluids. Let us see what the problem is. The velocity of a small ball of mass m, density d, when dropped in a container filled with glycerin, becomes constant after some time. Let us see how does this happens. When a ball of mass m, density d, is dropped in a container filled with glycerin, that means there is glycerin around. Assume this glycerin is yellow, right? It acquires a constant velocity after some time. How does that happen? Being a liquid, this liquid applies a upthrust always in a vertically upward direction on the body. And as the ball is dropped down, viscous force acts against the relative motion. As the body is coming down, viscous force also thus acts in upward direction. So the downward force is weight. Upward force is a combination of viscous force and upthrust. When these two forces are balanced after some time, because though the upthrust is, what's the formula for the upthrust? Volume of the fluid displaced, density of the fluid into gravity, that is always constant. But viscous force is 6 pi eta rv as per the Stokes law. 6 pi eta r remains constant, but as the body comes down, its velocity increases. As velocity increases, entire viscous force also increases. So the downward force is constant, but the upward force is increasing. So somewhere after some time, what happens is force downward is balanced by force upward. Then the ball or body acquires a constant velocity, and that constant velocity is also called terminal velocity. So at terminal velocity, force downward, weight, is equal to force upward, that is combination of upthrust plus viscous force. Now he is saying, if the density of the glycerin is d by 2, what is the viscous force acting? So let me write a formula for viscous force first, as weight minus upthrust. We know weight equal to mg. Upthrust as per Archimedes principle is volume of the fluid displaced, density of the fluid into gravity. Mass of the body can be written like volume of the body into density of the body minus volume of the fluid into density of the fluid into gravity. But here if you notice carefully, body is completely immersed in the fluid. Here, as the body is completely immersed, volume of the fluid displaced equal to the volume of the body itself, because that body pushes the fluid away. How much of the fluid away? Equal to the volume of that body that is immersed in it. So in the place of volume of the fluid, I can write volume of the body itself. It implies viscous force equal to volume of the body, density of the body into G, minus in the place of volume of the fluid also volume of the body, density of the fluid into G. So simplifying that, volume of the body common, G common, density of the body minus density of the fluid. It is given that what he is saying is, if density of the body is d, density of the fluid is d by 2. Substitute these two values in this equation. That implies viscous force equal to volume of the body into G into density of the body d, density of the fluid d by 2. So volume of the body G, d minus d by 2 is d by 2. What I got is volume of the body into density of the body into G. That's nothing but the weight of the body. Mass of the body, volume into density is the mass of the body into G by 2. That equal to mg by 2. That's the answer for the problem. That is that much simple to solve. So the only thing that you need to know is when somebody say it acquires a constant velocity after some time, it means to say the resultant force acting on it equal to 0. So the weight acting in the downward direction is the downward force. Upthrust is always upward. Viscous force is against the motion. As the motion is down dropped, viscous force is upward, and I have just equated these two forces and got the answer. That's how we solve the problem. Thank you for watching.